Good evening, guys. Welcome back. We will continue with our day 5 session. Okay, so today, uh, day 5 session, and the day, and I think the day. So, guys, whenever I type, it's the time only. Okay, anyway, it's not required. So, guys, why I'm doing all these things? Because that, firstly, when I give the drive to you, when I give access to you, you will get the notification. You will get like this actually, like day one, you will get the video notes and plus like the diagram which I draw. Simulate the day two, day three. Like this, I will give the entire drive to you so that you'll be able to get the like the device breakup actually. That is one thing. Secondly, what I will do, I will try to give a description about what I covered in day one here. Okay, I'll give the like something like I will create something like here like this. Uh, day wise topic. What is it? Topic summary. So like that, I will try to write a notes like this, like this. I will try to, I'll also try to maintain day one introduction to, like this, I will type it. Sorry, I'll maintain it. Introduction to DevOps. Okay. And deployment strategies like this. I will try to do it actually so that you will get to know what and all we had covered on the day one and day two, day three. Like that, I will try to maintain all the things from now. Is it fine, guys? So that it will be, you will be able to understand what exactly day one is all about, day two is all about, like that. Okay, so this is how I'll give the details, guys. For I mean, this is how I'll try to upload in the drive actually. Plus, I'll have a documentation folder also where all documents will be available. Topic-wise documents I'll be sharing like Docker, Kubernetes, Ansible, Terraform, Splunk, ELK. All I'll segregate all the tools in that inside the all folders. You will find all documents, PDFs, notes. It's not only my notes. I will also try to share some other authors' notes also so that collectively you will get all the data plus all interview question answers. I'll also try to share you some very good latest dumps on Terraform certification, Kubernetes certification, even like even GitHub action certification, so that what happened if you go through dumps, you will get to know about what are the latest question answers which are being asked in the certification. Plus I'll also share lumps and lumps of inter question answers, scenario based questions, intermediate questions, basic questions, so that you will get to know, right? What are the with the companies which they're asking, no, with the company interview, with who has taken an interview, okay, what time the interview was taken, what kind of questions they were asked, and for some of the interview question answers, I have even written the answers also. So it will be a collective, a lot of things. You will get the things, guys, so that you can go one by one. Okay, and don't worry about interview question answers, all such things, resume building and all. Don't ever think about it at this stage now because we are too early now. So that and all we will try to cover in each and topic. Like when I complete the Linux, I will try to take a Linux 2 sessions only on inter question answers, which they ask it. Similarly, when I complete the Git, after Git completion, I will take 1 or 2 sessions only on discussing on inter. So for every topic completion at the end, I will try to take 1 or 2 sessions only discussing on inter question answers so that you will get to know what are the important things which are asked in interview. There are some other questions are there, guys, inter question answers which would have not ever covered in our topic, but still I will take that. I'll also share all this question answers also to you so that you will be aware of. Okay. So same thing with all the topics, same with the cloud also. Even AWS also, I will give the dumps, latest dumps, what is there with me. I'll also explain about like what are the inter question answers which are being asked. Plus topic wise also we will try to learn all the things. Okay. This is how I'll share the drive to you. Okay. Fine, guys. So let's begin with our today's session, guys. So today I will be continuing with the Linux itself. So in the last session, we had covered some few things on Linux, right? Linux, how Linux was came to picture before Unix was there actually, right? And as I said, right, like whenever we work on any of this Unix or Linux based operating system, we always execute the commands, and commands is very important in our day-to-day activity. Without the commands, you cannot literally work on Linux operating system. So command have to be there. You take any operating system, like it could be Windows, it could be Linux, or it could be Mac OS, any operating system, you will find the command line terminal, or we call it just like a terminal, right? And with the help of a terminal or with the help of a virtual terminal. We call it as a terminal, or we can call it as a virtual terminal, or some people call it as a black screen. Like for example, like this in Windows, right? You have a PowerShell terminal like this. This is a terminal actually, guys. So if I type terminal and if I do a right click, run as an administrator, right? So you could see that actually this is the PowerShell terminal. I got it. I can execute any of this command like this, right? So we have, guys, so many commands are there for every operating system. We have a commands, like even for Mac OS also we have a commands actually. Linux, obviously, it is a command based. Earlier, Unix and all were command based, right? So when you come to the Linux or Unix, actually, when you come to the Linux or Unix, okay, graphical user GUI, graphical user interface mode is used very less. It means that literally, guys, in industry, even in the real time, or even at your home also when you're working, we don't use GUI much, because that we know that to make it effectively to work under the Linux, we always use the command line only. So only command line interface, that is nothing but the virtual terminal only is used actually. Is used in Linux. So always, guys, don't get fear by looking at this terminal. Some people have that fear saying that Rajesh, on Linux, because you will get only this terminal in the real time. It is something like this which I get it. How I will able to work it? Nothing, sir. Don't worry at all. You have to only know some commands. So when you know the commands, slowly, gradually, you will get a confidence that okay, I know this command, I know this command. Okay. Initially, it looks like a very big burden. Oh man, I have to learn so many commands. But eventually, over the period of time, say for example, if you're working within 1 or 2, 3 months, you will feel yourself very much comfortable. So that comfortable you will get once you come out from that fear of working on Linux, and when you start executing some commands, going through some commands, seeing the output of that command and troubleshooting certain things by executing certain commands, then only your confidence will build. So don't get any fear while working on Linux. I know many of you are working on Linux, you have been working on DevOps, but for those who are newcomers, who are very new to Linux, right? For them, I'm saying that don't get fear actually. And even some of you might have not worked on Linux at all. You might be working on Windows only throughout your life, right? Still, what happened? Need not to fear, because it's only a matter of some time where you need to practice in a system, where you need to open a system, launch the machine, and then open the virtual terminal and start executing some commands. Even though you are newbie, I would still suggest that please open the terminal and start executing the commands. That is my humble request. From the day one onwards, you have to start working on terminal actually. That's a Linux terminal, right? We call it as a virtual terminal. Am I clear, sir? Okay. Now, so that's how. Now, guys, what happened, right? Usually, I'm just telling you for your information. You not to worry. Like whenever we install, when we install Linux, actually, basically Linux will provide. Okay, by default, it will provide 6 text terminal or nothing but the virtual. Okay, and one graph or GUI terminal, we say. So Rajesh, will I get the graphical terminal like this? How it looks like a Windows? This is my Windows, right, guys? You could see that actually how I am able to see a GUI mode, right? So will I get the same thing in Linux also? Yes, sir. You will get the same thing in Linux. But how we are going to get this graphical user interface? Yes, sir. When you install the Linux, like for example, you install the Red Hat Linux. Okay, don't worry now, or Ubuntu Linux or anything CentOS Linux in your laptop, in your laptop, in your laptop, and and uh, that too you install the desktop mode, then you will get the GUI right mode actually, or GUI terminal. Graphical user interface. GUI means graphical user interface. So it means that Rajesh, when I take a CD, or when I take a USB drive which has the Ubuntu desktop mode installer, or else Red Hat desktop mode installer, or else CentOS, or any of the Linux flavor, when I install it, I will get the GUI. But in an organization, but in the companies, but in the organization, they never install desktop, desktop mode based OS, Linux OS at all. They won't do it actually because they don't need the GUI. GUI will kill a lot of RAM memory. It takes a lot of memory. It takes a lot of CPU cycles. Hence, they don't do it. They will just try to install without the GUI mode. When you install the GUI mode, guys, when you install without the GUI mode, then you'll only get the text terminals. But when you are installing the Linux in your laptop, the desktop mode, right? Then by default, you'll get 6 text terminals and 1 graphical terminal. So Rajesh, why I need all this information? Is it really required? Yeah, to some extent it is required. Why it is required, I will tell you later. Why it is required. But right now you just understand. Okay, Rajesh, when I take a Ubuntu image, which is a desktop image, and install in my laptop, you will get 6 text terminals and 1 graphical terminal. That's all. Okay, but for an industry, no GUI mode at all, no graphical user interface mode at all, only text based. So in that case, Rajesh, when I have in industry, when they install Linux actually, like Red Hat Linux, when they install in some server, you're saying that only 6 text terminals are coming. But I need more now in the industry. You need more and more terminal because so hundreds of people will be logging in the Linux machine and they'll be working. A lot of engineers will be working, right? Do you think that 6 is sufficient? No, 6 is not sufficient. Then in that case, sir, oh, you'll get plenty of terminals. So plenty of terminals, you're going to get it actually. Like how many terminals? Right, 4 terminals will get. Oh, it means that at a time 4,000 people can log in and work on terminal, work on Linux operating system in the server. Yes, sir, you can work on it like that. Plenty of terminals is of terminals. Will be there in the organization, right? Because they will configure it. The system admin who is there, right, he will configure such a way that you will get plenty of terminals. You need not to worry at all, but there will not be any kind of a GUI mode. Graphical interface, rarely they'll have it, but they don't have it actually. Am I clear, sir? Okay, guys. So this is something which I thought I will tell. I'll start by telling all these things. Okay. So now, what exactly we had covered yesterday, guys? So yesterday we had just covered that Linux is like an operating system. It's a set of program, or it's a system program, or it's a system model that controls and coordinate your hardware resources. So whenever a user want to communicate with an operating system or want to communicate with the hardware, he can communicate with the hardware with the help of a operating system itself. So if you go to the day 4 and if you saw this diagram, if you remember, you saw this diagram. See, whenever an end user he want to communicate with the hardware, he can communicate with the help of an OS itself. OS has all those programs so that whenever end user he want to communicate with the hardware, he want to communicate with the hardware means what? Suppose you have a keyboard, you have a mouse, okay, you have a camera, right? Or you have something like a keyboard, or you have something like a sound USB device. Any device, when a user want to communicate it, he has to communicate via with the help of a OS itself. OS will communicate. Okay. So Rajesh, now the question comes, right? The end user is something like Rajesh who's sitting in our system. So he will communicate to the OS. Okay. The OS communication happen from, sorry, the end user communicate to the OS, and from the OS, the communication happen to the hardware. So there is a two-way of communication, right? From here to here, from here to here. Yes, sir. Okay. Fine. Got it. Now, so this is a end user. He's an end user, right? So he's an end user. So who is an end user? Like Rajesh is an end user. He's sitting in the laptop. He's sitting. So whenever Rajesh is executing any commands, is executing any commands. So Rajesh, while executing any commands, so is any communication happen between the Rajesh to the operating system, Linux operating system? Yes, sir, it happens actually. So you have Linux OS. So whenever any command is executed, so the communication will happen between the Rajesh to the OS. It means between the user to the OS actually. Okay, what are the other ways where the communication can be made? First is command. Second is something like you call it as a system calls. Don't worry about this now. What is system calls? Okay, the first method is commands. Second method, third is through some signals. Fourth is through some interrupts. Fifth is through some IO operation, IO, input output operation, we say. Okay, and the sixth is through the proc file system. This will look heavy for you. What is this? Something Rajesh is something telling new thing. Don't worry, guys. This is something which is not DevOps engineer doesn't know all such things. I'm just telling you. Okay. So Rajesh, first is through the command. Yes, sir. First command execution will happen. Okay. When executing any command, so first command, you can make a communication. This is the first option. Second is something system calls. Okay. So, okay. Some people will call this as an API. APIs. Yes. System calls or APIs. It's synonym on the same. API means application programming interface. Don't worry about this as of now. Okay. Third is signal, interrupts, IO operation, IO blocks, and sixth is a proc file system. So this is how the communication happen, guys. This is the only way. So Rajesh, is there any other way apart from this the communication can be made? No, sir. These are the only ways. It means that whenever a user executing any commands, the communication will do happen from users to the operating system. Whenever the user is calling some APIs or system calls, yeah, communication will happen. Signals, communication happen. Interrupts, IO, proc file system, everything happens from users to the operating system. And from the on operating system, it starts communicating with your hardware. So what's an hardware, guys? It could be a CPU, it could be memory, could be your it, storage, it could be what do you call it could be what is it? It could be your USB device, sound card, audio card, video card. You take any device to your connected system, audio card, graphical card, or network card. Thing, guys, anything the communication has to happen. It has to happen via with the with the I mean the operating system will actually communicate to this hardware. Actually, very good, sir. Okay. And this OS, Linux OS, as I said, right, it is made up of some 5 components. Process management. It means that you will ask Rajesh, what is OS is made up of? OS is made up of process management, file management, device management, network management, memory management, and network management. Like this. So OS is made up of all these 5 components. Now, one question will come to the mind, Rajesh, does a DevOps engineer needs to know all this in detail? In my previous videos also, guys, I have told many times that it is not really required, but if you want to become a very fantastic, very good very good DevOps or cloud engineer, yes, it is always good that you need to have an in-depth knowledge on all these topics so that you will get when you why this much knowledge required when you are troubleshooting in the real time, when you are working real time, all this knowledge information will be indirectly to be used at your workplace while troubleshooting. So that is how this knowledge will increase your learning capability. It'll enhance your knowledge. It'll increase your learning capability. So please always, whenever you learn any new things, guys, please always open your mind to so much extent that you should learn all in detail concept, even a lot of tough topics also you should be able to, you should have that capability to learn all the things. So I would request always open your eyes, open your mind to learn, to grasp as many information knowledge as possible. Okay, don't learn in a very shallow way, don't learn in a very particular way. Okay, I want to only learn this much. Oh, I will get a fetch a job with this. You will fetch a job. I'm not saying that you can't fetch a job, but it will what happen, right? It will not increase your knowledge skill set. So a person who has an open mind to learn many things, right, only that is the only guy who will be capable enough to learn a lot of tougher things also. So please always think that I need to learn in a very in detailed way. I need to learn a lot of tough topics which are going to come up. So always open your mind in a very broad way. Open it completely and learn many things. Okay. So this we will discuss in some time now. Don't worry. Now, okay. So Linux operating system is made up of all these 5 subsystems. So 5 subsystem of Linux operating system. Now the question will come, Rajesh, is the same subsystem, even many other operating system have the same subsystem? Mac OS, Windows OS, Linux, Unix. Yes, sir. Almost all operating system which exist, right? All operating system is made up of this 5 subsystem only. Even Windows operating system also is made up of process management, memory management, file management, device management, and network management. There could be some more other managements, but these are the 5 core managements will always be there in most of the operating system. Okay, and as I said, right, this Linux operating system is completely purely written in the C language. Even traditional Unix also is written same language. Whereas many other OSs like Mac OS, they have used the Mac OS. It's not but Apple company. They have used their own language for writing a Mac OS. Similarly, Microsoft company have used their own language to write the Windows operating system. So we are not worried about those things. I'm right, but whereas Unix or Linux, particularly Linux, I'm saying it is purely written in C language only. So if you remember, I told you that the first the Linux was designed by a person by the name Linus Torvalds here, right? Linus Torvalds. I think somewhere I've written it, right? See, Richard Tallman and the Free Software Foundation, and I think I didn't told you, right? Yeah. So Linus Torvalds, see, can you see it? Linus Torvalds is a guy who has designed the Linux operating system. So he's a fellow who has maximum contributed for designing and developing this management, different management of the operating system. He has contributed a lot in the process management, the entire file system, most of file system operations, everything is written by Linus Torvalds. Device management, memory management is purely written by Linus Torvalds. And network management is something he has took from the traditional Unix operating system. Some more things have been added by him and many other team member and a lot of other freelancers, a lot of open source contributors. They have designed a lot of things. So it's a combination of many things. Right? Many people have contributed, but the main person who is the key person is a Linus Torvalds, right? And there are many people in his organization. Like as I said, Linus Torvalds has its own organization. He released the Linux kernel, new kernel in the kernel.org website, right? That's a website where he will try to release the new kernel, right? Linux kernel.org, right? Somewhere I've written. I've not. I think I've written yesterday. I was saying right, kernel.org. Yeah, kernel.org. This is the site, guys, where Linus Torvalds and his teammates they upload it, right? They upload a new Linux kernel every once in 6 months, actually, right? The stable version they release it, and the first version which was released was 1.0.0. Now the latest version we saw was 6.17.1. So sometime what happened that you should be aware of on which Linux kernel version you are working actually. So it's 6.70.1 is the latest. Maybe in your organization you might see that 5.10 is used, 5.12 is used. Some other organizations are still using some very old like 4.8, 4.12, 4.16 like that. You can't say that. But whichever Linux version which the industry uses or the organization, it will always be a stable kernel only or the stable operating system. Okay. Now coming back here. Okay, let me go to the diagram. Yeah. So now user communicate to the Linux, Linux communicate with your hardware. This is the hardware actually. Now the question comes, Rajesh, like, okay, fine. Does a Linux operating system directly communicate with the hardware? Yeah, it communicates, but actually what happens in between, there will be a layer here. We call it as a HAL, hardware abstraction layer, HAL. So what happened, the Linux kernel will actually communicate with the hardware abstraction layer. And from the hardware abstraction layer, it communicates with the hardware. Like this, it happens actually. Okay, fine, good. Something I got to know now. Okay, Rajesh, whereas a end user like Rajesh, he want to communicate the OS. So he will communicate the OS with the help of a command, system call, signals, any one of this. But most of the time, the user communicates the Linux with the help of a commands, with the help of a system call. These are the two major things through which the communication do happen, right? So now, whenever user is actually calling a command or calling an API or system call, the communication happens from users to the kernel or users to the operating system, right? But is there anything which in between as HL we have, is there any in between? Yes, sir, there is something in between here. We call that as a shell. So again, the definition changes now. The user, if he is issuing a command, if he is issuing an API, the communication happen between the user to the shell, and from the shell, the communication happen to the operating system like this. Am I clear, sir? Here, shell is there, and in Linux actually, the default shell is a bash shell. Bash is a default shell. Okay. Bash means born again shell. SH means shell. Born, BORN, born. AGAIN, again shell. We call it as a born again shell, which is nothing but BASH, the full form. The full form of bash is born again shell. So these are default shell, guys. Okay. So whenever a user want to communicate, he communicates with the shell itself. So till here, guys, did you understood? Guys, you have any question? Do you have any doubts here? with this diagram. We will dig more and more in this. Don't worry. We'll dig more and more, guys. Vishnu, Vedant, Krishna.
No doubts.
It's fine, sir.
Good. Yeah. Now, okay, this is something a picture, guys, which we have to keep in mind actually. Good. Now, now the question comes, okay, Rajesh, you said something about Linux. It has all these 5 components or 5 subsystem. Okay. So guys, usually what happened, right? This all these files, 5 subsystem, okay, all these subsystem, all these 5 subsystem, actually we call it as a kernel. What we call? We call it as a kernel. Kernel, kernel. So Linux operating system is nothing but it's a kernel only. So if you take a Linux operating system like this, if I take this around like this is a Linux operating system. But here what happened? Your 95% of the Linux operating system like this, 95% of your Linux operating system is nothing but a kernel only. So it means that Rajesh, all this 95% comes here. Yes, sir. What about this 5% then? Yeah, this is what the HL, which I was talking about. So this entire thing is nothing but we call, in short, we call it as a Linux kernel, or we can just call it as a OS. That's all. If I say OS or kernel, if I say Linux OS or kernel, it is one and the same. You need not to, you need not to get confused. So when I say Linux kernel, if I say Linux OS, both are same actually. There's no difference. So does the OS, does the kernel concept comes even in Windows operating system or Mac operating system? Yes, sir. The kernel concept comes there also. But Windows people or the Microsoft doesn't call it as a kernel. They call just as a Windows OS. That's all. They don't call it as a kernel. But whereas in Unix or in Linux or in the flavor of Linux or Unix, wherever you take Unix or Linux, there they call it as a kernel only. A kernel is something which they understand. Okay, it's a main core of an operating system. We say. So what is a kernel means? Kernel is a main core of the operating system. 95% of your job of the operating system is done by the kernel only. And we call kernel as a non-detachable part of the operating system. Right? And the remaining 5% is nothing but a HL, hardware abstraction layer, we say. Right? And again, if you want little more detail about the HL, HL nothing but it is a firmware, guys. It's a firmware, actually. It's a firmware where the the assembly instructions, assembly level instructions are embedded. So what is assembly level instruction is? See, these are the assembly level instructions where what happened, right? It has all the hardware related assembly instructions will be there. So how it happens means the kernel or the operating system, it actually communicates with the HAL like this from here to here. This HAL will still more in the lower level device which it has to communicate, right? It has to communicate via the assembly level instructions only. So some kind of a machine instructions or like, or else I can say that assembly level language instructions only it can communicate it actually. So guys, now what happened, right? Now the thing is that actually, see, for example, like you have this hardware. Okay? You have hardware. Assume that this is my USB actually USB device, or I can say that USB device. Have you seen USB devices, right? Right. I mean, I'm very sure that you have seen this. This is a USB device, right? This is the USB device, right? You have seen your pen drive, right? This is all USB device, right? Right. Now the thing is that actually that this is a USB device, guys. This is a USB device. Now what happened, right? You have a kernel, you have an operating system. Kernel or Linux kernel or operating system, Linux kernel or whatever you call. Now the thing is that whenever the Linux operating system, it want to communicate with your USB device, it can communicate via with the help of a lower level assembly language instruction only. It communicates with the assembly instructions only. Always, guys, whenever the OS has to communicate with the devices, it can communicate only with the assembly level language instructions only. Okay, so this is it depend upon the processor architecture, because we are working on the x86 processor, because our laptop is x86 processor architecture. Then what happened, right? Your OS, the Linux kernel, will have the x86 assembly instruction with it. So with the help of the assembly instruction, it communicates it. But who actually does it? Actually, it's not Linux OS widget, which is nothing but HAL, which again, it's an embedded code within the Linux kernel only. That 5% which I was saying, no, that will be there. That actually communicates to user, because it understands the hardware abstraction layer. It understands the assembly level instruction actually. That's what it communicates with the USB device. Similarly with the serial port, similarly with the parallel port, similarly with the network card, similarly with the audio card, video card, similarly with any kind of a device which is connected. You might have connected to your you might have connected your printer, you might have connected you some projector, you might have connected any device you connect, guys. The Linux operating system can detect that device, and it can communicate with that device with the help of a HL only. So I think, guys, now you got some big picture. Somewhat you are able to understand like how the communication happens. So again, the same question comes, whether we want to know all these details. Not really required, but it is good that okay, we have some basic understanding. Okay. Now coming back here, guys. So because the Linux OS is made up of these five subsystem, let us try to understand what is this all about five subsystem. I will not go in very in detail, guys, but I will give you on a very high level what these five subsystems are. Okay. I think I've already written it. Let me copy from my previous notes. Right. So just one line information, guys, because okay, so that I will try to quickly complete this actually. So file system is nothing but it is a file system. So Linux, Linux supports many file systems. So guys, one question I want to ask you: which is the file system which is there in Windows? Can anyone tell me? Windows? How come suddenly many people dropped? Krishna, do you have any info knowledge? Navid, Pankaj, Suket?
Rajesh, I actually seen in your video, but now I didn't get it now
No,
at
in
this
Windows.
moment. So
Naveen,
in
in
Windows
Windows.
only. Yeah,
Yeah,
in
Naveen.
Windows. Yeah.
You go to the C drive, man, like this.
Okay.
You go to the properties. What you're seeing here?
Oh, yeah, NTFS. Yeah, I thought
Yeah,
NFS. Sorry, I
yeah,
was searching.
yeah. Yeah,
Yeah.
yeah. You can search when you can say you can Google it out or whatever. But I'm just saying, okay, fine. So NT had a file system like EFAT or FAT32 like this. Like, now the latest is NTFS. Latest is NTFS. So Linux supports many file systems. It supports a Windows-based file system. Okay, it supports the Linux-based file system like ext4 file system or ext5 file system, extended file system. We say it supports even NFS file system, Samba file SMB calls it Samba file system. Okay, NTFS system. Okay, HDFS file system, HFS file system, AF file system, Omega class file system, right? HP India file systems are there. So like the more than I think 40 plus file systems are there. Like there's almost all file systems are supported by Linux. How Linux supports so much file system? Because file system is one of the modern Linux kernel. How it supports so much file system? Because it is because of VFS, virtual files. Virtual file system is one of the component within a file within the Linux kernel that supports all this file system. Now, why we need a file system altogether? See, guys, whenever we have a storage, whenever you have any device, right? Like storage there, like storage is there. Like for example, hard disk, CD-ROM, floppies, or USB. Anywhere you take any storage, actually, right? The OS, the operating system, can communicate with the storage with the help of a file system only. It means that file system should be there in the storage. With the help of that storage, with the help of that file system only, the Linux kernel can communicate with it. Like for example, here. You said, Rajesh, I have a hard disk. This is my hard disk, Rajesh. Okay, fine. This is my hard disk, right? And the hard disk has the partitions like this, actually. It has a partitions like this. Sorry. It has like these partitions. This is something like 4 partitions are there. So this is something like one partition like this. This is one partition, right? Like this. These are 4 partitions. This is your hard disk actually. Hard disk. So I created some 4 primary partition like this. Now what happened, right? Your operating system or the kernel, this is a kernel, this is the kernel operating system. It actually can communicate with this hard disk with the help of a file system only. It can communicate with the help of a file system only. Now, suppose you say that Rajesh, this yellow color file system, whatever you're saying, right? This is the NTFS file system. Assume that Windows based.
Rajesh,
So in
you're
this,
not speaking or
hello,
how?
man, what is this, man? Nonsense, sir. Hello, can you hear me? Hello.
Yeah.
Rajesh.
Yes, Rajesh.
Sure, nonsense, man. Last time also happened same thing. Sure. Guys, you interrupt me in between. So you got to know, right? I'm doing something and you're not listening. Miss, no, you know I'll be keep talking. So just consider that. Okay, and I think I have to replace my headphone. Let's see, man. I'll try to replace it tomorrow. Yeah. So what I'm saying that this partition has the Windows interface file system. This partition, green color, is nothing but your Linux ext5 file system. ext5 file system. Now the question comes to Naveen and many other people like Rajesh, what you mean by this disk is taking and you are saying NTFS? Man, you have formatted this partition or this part of the disk with the NTFS file system. You formatted, you took this disk of this and you format with the ext file system. You took this disk and formatted with the CramFS file system. You took this disk. So basically what happened, this entire disk you have partitioned to 4 partition, and each partition you are formatted with the new file system or some other file system. Whether Linux kernel can support, yes sir, it supports it actually. How it supports, because as I said, right, it has something with the VFS, virtual file system. Because of this VFS concept, what happened, right, your Linux kernel can support n number of different file system. So one of the component of the Linux kernel here in this case is your file system itself. So what is a file system it uses? Rajesh, whenever I want to create the file or whenever I want to delete the file, whenever I want to change the ownership of the file, of files, or whenever I want to create a file, even you can even create a folder or we call it a directory also. So in Linux, guys, we call it a directory. Whenever you create a folder like this in Windows, how do you do create a folder? You do a right click, go to the new and just create a folder like this. I'll say that Ravi something. I will give the folder name. This is the folder name. Same thing in Linux, we call it as a directory. So I will do all this practical, guys. Don't worry, because we have to launch Linux and show you. I'm just telling you. So whenever you want to create a file or a directory, you want to delete that file or a directory, you want to change the ownership of the file or a directory. Okay, you want to transfer the files from one source to other source. So it means that you are actually doing some operations onto the files or onto the directory. So who does all those things? Your file system management do all those things. Similarly, what happened? Your memory management is nothing but it manages all the memory. It manages all the memory. It means that you might be having your RAM memory, right? Right, guys? You might be having your hard disk actually, right? You're doing so many operations onto the RAM memory, right? It means that by default, what happened? Your operating system will be running in your RAM memory, which we call the primary memory. And your hard disk is somewhere, it's a secondary memory, we say. And where all your file system and all your data are stored. So whenever you want to manage the data, whenever you want to transfer the data from your primary memory RAM to the disk or from the disk to the RAM, you want to do a lot of transmission, you want to communicate, with the memory. Means memory management model in your Linux kernel is required. So Linux kernel also has a memory management. So you will get all kind of a different addressings, like for example, virtual addressing, linear addressing, physical addressing, and also like what happened, right? In Linux kernel, we have so many different tables are there, like memory management related tables are there, right? Like for example, slab allocators are there, two-way paging, three-way paging, algorithms are there. All are managed by the memory management. See, I don't want to really make you, fear. I'm just saying, this and all you need not to worry. Three-page address translation in Linux kernel. Three. Address translation. See, kernel.org. See how exactly do Linux kernel virtual. So you will get some many good articles, right? Where you know that you will be doing a lot of translations, address translations like this. 1 second, guys. Only 1 second. What I'm trying to tell that this paging, memory address translations, these are something which is a part of the Linux kernel only, the operating system does. So Rajesh, do I have to really learn all these things? No, man, you need not to learn all these things. See, 32 paging, page physical extension. So all these are something very fantastic concept, guys. I mean, which we need not to worry, but I'm just saying that, okay, we have all the things to learn actually. Okay. So now, so all these are memory management things actually. Okay. So Linux kernel also has that actual memory management. Okay. Okay, so process management is something which it requires, or it takes care of creating the processes, terminating the processes, and having intercommunication between the processes. So that's what the process management is there. So process management is something, guys, where whenever you want to execute any task, whenever you want to execute any command or task. Say for example, Rajesh, I want to launch the Google. So what you do, you go to the browser and you do a double click like this. So browser is launched. So how this browser is launched? How exactly this browser was launched? Because guys, in your Linux kernel, as soon as you go, a user is doing double tap. He's doing a click twice on a browser. What your Linux kernel will do, it will launch the browser like this. So when it launches the browser, in turn, it means that your Linux kernel is actually creating a process for it actually. So a process will get created like this, like this. A process will get created like this. This is a process will get created like this in the Linux kernel. In your Linux by Linux operating system, a process will get created. A process will get created like that. That process will take care of this application. What is the application? This browser application will take care. So whenever you're executing any command, suppose if I go to the terminal and if I do a dir command, I'll execute a dir command. So the command is executed. But how this command is executed, Rajesh? Dir. The command is executed because that in Linux kernel, the Linux kernel will create a process for that. And that process will take care of execution of this command. Did you understand, guys? Whatever I said so far? So whenever you execute any task, any command, Rajesh, I'm executing 100 tasks in my operating system. It could be Windows or Linux. How does all those 100 tasks or 100 application runs in my system or in my Linux machine or in my Windows machine? Because for each and every task, guys, the Linux operating system or the Linux kernel is going to create a process for it. For every execution of a task or the command or the application, a process has to be there. Who will create the process? As per diagram, Linux kernel will create the process. But actually, in the Linux kernel, who is the one who will create the process? Yeah, the process management will create a process. Okay, got it. So it means that, Rajesh, whenever I'm running any command or system call or any application when I'm running, in turn, the process management, which is one of the subsystem of your Linux kernel, that will take care of creating the process. Okay. Apart from that, what are the other things it does? It also terminates the process. Whenever you don't want the process to run or whenever you want to stop the using that application, automatically what happens when you stop that application, the process will also get killed actually. And having an intercommunication between two different processes. It means that, Rajesh, when we are having two processes like this, like process A and process B, if there are two processes like this, process A and process B. So in Linux, generally in Linux or in Unix, anything, we call one process as something like a parent and one process we call something like a child. What is a child, a parent? Don't worry now, I will discuss all these things. Okay, whenever these two processes, it want to communicate each other, it can communicate each other with the help of some of the techniques. Like, okay, so that is something like pipes, FIFOs, semaphore, message queues, shared memory, like this. So whenever you want to communicate between two different processes, we will be using all these things, guys. So what are these things, Rajesh? This is nothing but inter-process communication tools. You call them IPC, inter-process communication tools. If you just go and Google like this, IPC tools in Linux. See, mastering IP tools. Can you check it out? Shared memory, message queues, semaphore, pipes. See, am I not writing the same thing, guys? Pipes, FIFOs, message queues, shared memory, semaphores. Semaphore I've not written, but I'm just saying it. See, Rajesh, all these things are required by the DevOps engineer. Not really, but the knowledge is, if you have a knowledge, it is good actually. Whether indirectly, when I'm learning many of the tools, like for example, if I'm learning a tool like uh, MSK is nothing but the Kafka. Kafka tool uses the shared memory, guys. Okay, Debezium tool will use a shared memory. Internally, it uses shared memory. Okay, when I'm using a service in AWS, a service known as a what is it actually? A service on the cloud front. Does the cloud front uses something like a message queue? Yeah, it uses. See, those services which are there, no, the intern uses all these services actually. Intern uses these features actually, but we are not aware. As a DevOps engineer, I need not to know that much depth, but it is used actually. Got it? So now, don't worry, I'm telling in a very high level, I'm showing you the picture from 10,000 feet, I'm showing you the picture. Don't worry, slowly when you go inside, you will learn many new things, you will learn many other new things, and also you'll be able to compare, you'll be able to learn in a better way. So that we will see it in a coming period, like how we can, in detail, we can learn many things actually, okay? But right, as of now, you have to just say that, okay, some 5 subsystems are there, which Rajesh is saying, and each and every subsystem does some job actually, okay? That's all. Okay. Now, network management, basically, it manages the network. Manages the network means what the management, like in networking, we call the packets actually, right? So you need to transfer the packets from one source to other source, from one machine to other machine, right? And you want to, you will be using a lot of network protocols actually. Like for example, you use a TCP protocol, you use UDP protocol, right? You use a protocol like SMTP protocol, right? You use some protocols like FTP protocol, SSH protocols. So Rajesh, all these protocols all are network based. Who manage it? All network management model of your Linux kernel manage it. You want to transfer the packet from one to other machines. Yeah, network management does it actually. So how it does it actually? There is one concept known as a sockets. Because of the sockets only, it does a lot of network communications. So sockets has to be there in network management. Without sockets, you cannot communicate. You cannot even communicate any of this protocol also without the sockets. Sockets have to be there actually. All these protocols, guys, TCP, IP, UDP protocol, or you can say TCP, IP, any kind of a protocol you take, all this protocol works along with the socket actually. Okay. So what is socket programming or what is socket in Linux? If you just type and check, right, you will get many information. What is socket in Linux? Like this. See, what is Linux or how the Linux uses the socket. See, they have given beautiful article, guys. You can just go through it actually, right? What are Linux sockets? See, port number. Each Linux socket consists of a device IP and a port number. How those communications happen, how the client server communication happen, TCP/IP, UDP network protocol, application level protocol like IMAP, MOP3, SMTP, FTP. See, inter-process communication also uses this one. You have something like unique domain socket, Redis. See, Redis cache, MySQL database, REST API. They all are socket based only, guys. So these things, guys, I will try to cover all this in detail in some time, not now. If you execute this SSH command, see, all these are getting, it in turn uses the socket only. So now, don't you think, guys, when you're learning in detail, we need to know all these things in detail? By executing this command, I'm getting an output, fine. But don't you think that, okay, I need to know a little bit more in detail so that I can better understand how you're getting this output? So that is a real challenge in everything in DevOps, or it could be in DevOps, or it could be in cloud, or it could be in data engineering, or it could be in AI. Anywhere you do, right, you need to always think in a one level, two level deeper way to understand how things are actually working. When you get to know that level of knowledge, no, definitely, guys, you will shine in your field. I'm damn sure. Rock socket is there, sequence socket. There are three types of sockets are there. I will discuss about those things later. Okay, these are the protocols. Don't worry about these are the APIs which the communication happens. So this is very good link, guys. But I'm just telling you, don't worry about all these things. We will revisit again when I take a networking detail. When I take the class, no, we will cover all these things in detail. But that network management of your Linux kernel, will support all these things actually. Okay, good. Fine. Now, device management. So device management is also one of the subsystem of the kernel. This is also one of the subsystem of the kernel which manages the devices. Like, see, guys, in whenever you have a machine, you have a hardware, like you have a big rack spaced no hardware is there, right? Or else you have a simple laptop or anything, right? Whenever you have any kind of a devices, of course, lot of devices are connected with that. Lot of separate different devices are connected with your hardware actually, right? With your system, sorry, with your system. Now what happened whenever your Linux operating system or Linux kernel, it want to communicate with various different devices, right? It can communicate with the help of a device driver. So also Linux operating system, Linux kernel has a lot of device drivers, like the device driver, like character drivers, block driver, network drivers, USB drivers, mouse driver. I'm taking mouse driver, no mouse drivers, and many other miscellaneous drivers. See, you are having so many drivers, guys. All these drivers, what these drivers will do, device drivers do, they will drive the devices. They drive the devices. That's what these device drivers are there, right? So all your device driver programmings, everything will be there in your Linux kernel. So Rajesh, if I want to really check all those devices drivers model in Linux, actually there is one command is there. I'll tell now only. There's a command by name lsmod command. Lsmod command in Linux will show you, will show most of the device driver, device driver models. Anyhow, I'll execute all these commands in a later upcoming session. Don't worry. So now, guys, now what you understood that in the overall, Rajesh, when I take this, Linux kernel, Linux kernel has all these different subsystem. Yes, Linux kernel has all. Each and every subsystem of this kernel, it does some operation. And all this management, guys, all this process management, file management, device management, they intercommunicate each other also. Like file system management communicate to the process management will communicate to the memory management will communicate to the device management, and of course wherever the networking is required, it communicates to the network management, right? These are all are working together. That's what this whole code is compromised everything. It is packed with one like image like anything, and that image we call as a Linux OS. It is packed. It is all tightly packed together. So Rajesh, all these are codes actually. Yeah, these all are codes only, process memory. So somebody would have compiled this. Somebody would have compiled this whole thing, and they have created some very good executable file, and they packed with the executable with many other files, and they are running as a Linux OS. Yes, sir. It is like that only. They are packed together. They are running as a Linux OS only. Am I clear, sir? So guys, I think with this you understood something right about what is a Linux kernel is all about, Linux operating system, how the communication happened between the user to the kernel, from the user from the Linux from the kernel to the hardware. And we got something, we saw something today is something, there is something like a shell is there. Okay, we'll discuss more about this in our upcoming session. There is something like a HL is there. Yeah. So Rajesh, why need all you need all this information, so many information, right? We need all this information. We need all such information. All we need all such small information. We need all these things because while troubleshooting, it will help us. While troubleshooting any problem, this knowledge will help us. That's all, guys. So guys, so you will say that Rajesh, then in case of a DevOps tools, you are saying that you have a Git tool, okay? You have something, as a GitHub Actions, yeah, correct. You have something even like a GitOps also. We'll see what is that GitOps. We have something as an Argo CD, okay, fine. You have something known as a Terraform. We have something known as a Docker. We have something as a Kubernetes. We have something known as a Ansible, right? We have something known as a Kafka. Okay, we have something known as a Redis cache or a Redis cache DB. Okay, we have something known as a monitoring systems, monitoring tools, like for example ELK. Okay, like for example Datadog. These are monitoring tools. ELK, this one, and we have something known as a Splunk. Okay, fine. So Rajesh, there are so many, like we have so many different tools are there in each and in the DevOps actually, right? When you are learning in depth, in detail about all these things, guys, when you're learning in a very in depth, you'll be able to troubleshoot any of this issue in this tool actually. If you are learning in a very shallow way, in a very narrow way, then you will not be able to troubleshoot it. You will find difficulty in troubleshooting. You will start asking help from the other people in your team. This is the disadvantage. So never ever try to become a shallow learner in all these tools. You'll try to learn in in-depth so that it will help you to troubleshoot. It will also help you to understand in a better way. It also help you to even what happen, suppose any new task is given. Suppose you are an expert in Docker. They'll ask you, okay, Rajesh, can you implement this in a Docker? Okay, instead of overlay network, can I use some other networks? Like, sorry, instead of bridge network, can I use anything overlay network? Right? Like, or else can you add this feature to the Docker so that it supports for our requirement. So you'll be able to do better things, guys, in all your project work, everything, when you have an in-depth knowledge in each and every tool. So that's what I said, that when you are learning, guys, learn in a very better way so that you'll be able to understand, and also it helps you to troubleshoot any issue in the future actually. Am I clear, sir? I think with this, like, you got to know something today. Okay, fine, good. Now, okay, any questions so far? Yeah, LSPCI, right? Correct. LSPCI will show you all the devices. So there are many commands are there, Krishna, for execute. For when you execute it, you will show it. LSPCI is something like it will show you all the devices which are connected. What is a PC? What is a who is the owner of that device? Like what is a device ID? What is a system ID? You will get many of the information with help of a LSPCI command. Right, that's a good command only. Right, you have LSPCI. LS mod is a command which will show you all the models which are devices which are running in the kernel space, which are in kernel space. That's what you have to say. But anyhow, we need not to really worry much that one about this ls mod command. When it comes to, I will tell about all this in detail actually. Okay, good. Now, okay, coming back here, guys. Today it was mostly like theoretical. It happened, but anyhow, we needed all these things. That's what it is, on one-time learning. So, but you have to learn in a good way. Okay, there are many in-depth knowledge is there, guys. Some of them I will tell. Some of them I might not personally tell it because you will, you might get confused, or you might think, what is this? Something Rajesh extra he's saying it. We are not able to understand. So don't think all these things, guys. Like you learn as much as possible. Many of the other things are there. If you're not learning, if you're not understanding also, no problem at this stage, because you are a new learner now. So many things might go above your head. Some of the things you might not really completely understand it. Okay, that don't worry. Keep just go to the video again. Ask me some questions, anything. Google it out for everything. Google is our best friend. You will get some information. Later again, you discuss with me. You call me in the WhatsApp. Ask me, Rajesh, what is this? What is this? So when you are trying to interact every day, every then and there, when you start interacting with us, with me, and with our group, and with the people within our group, right? Then only our knowledge will increase. So in that way, guys, only your knowledge will get increased. That's what I would highly recommend, that in our WhatsApp group you start putting all the messages. Rajesh, this is the command I found. Rajesh, this is what it is. Any one of our people in a group now, they might even look into it, or they might even respond to your questions or something like that. Okay, so keep learning. That should be there every day. There has to be some new learning. Okay, right, good. Now, okay, guys. So far, so good. Okay. Now, the thing is that, right? Now, in Linux or in any operating system, okay, there is something we call it as a booting process, boot process. So, what is this boot process all about? So, guys, boot process is something, what happened, right? When your system is switched off, it is switched off, so there is nothing, your system is not running, or your laptop or your server is not running. So suppose, in case, for example, I want to switch on my system, I want to make my system up. What you do, you'll just do a power on, right? You supply the power to the machine. As soon as you put the power on the supply machine, some kind of a initialization happen in your device. You could see that some LEDs are blinking. You will see that suddenly the fan will start running inside your in your laptop or in your server, right? And a lot of blinks will happen. If you have connected your machine to some kind of a desktop or to the screen, to the LCD or LED screen, you will see that some message will start throwing in the screen. So what you understand, okay, my system is started, my device is getting initialized. Okay, I will, in some time I will see that my operating system also comes up. That's how you will be waiting for, right? So whatever you are seeing, guys, whatever the things is happening in front of you when you are observing, that's all entire thing we call as a boot process. In the back end, something might be happening which I'm not aware, but whatever you see, like the system is getting on, LED is getting on, fans are running, screen is getting displayed, some kind of a pop-up messages are coming in the screen, and you'll see that so many messages are coming like this. Okay, this is initialized, this is initialized. Finally, you will see that there is something like a GUI screen will come where it will ask you to enter the username and the password. So if when you are a owner of that machine, when you enter some username and when you enter the password, you will log in and you will get the desktop like this. Like this, you'll get this desktop. Like this. This is the desktop, I got it, right? So all these guys, since you power on the system, finally getting a desktop, this whole process we call it as a boot process actually. So this is applicable to any operating system. It could be Linux, it could be Windows, it could be Mac OS, it could be any other operating system, right? The boot process, what happened, right? It is a process through which actually the initialization of your operating system happens, and finally you will get a stage where a user can log in with his user and password, and he can log in into system. So till that process, till that stage, entire stage, what we call as a boot process actually. So boot process has a lot of steps. Okay, a lot of steps it has. Now what happens basically, guys? Assume that this is my laptop. This is my laptop. Inside my laptop, I have the hard disk actually, like this. This is the hard disk, right? And this is my RAM memory. You know about the RAM memory, right? What is RAM memory? The RAM memory, right? You have a RAM memory, and you have a display or the screen, something like this. You have this like this screen. This is nothing but your like your screen or your monitor or your what do you call your LCD display something. We can use any of those, right? We can use any of the terminals. And also, like, you have here something, Rajesh, you have the CPU. This is nothing but your CPU, right? This is all I'm talking about in laptop, I'm saying. And there are so many devices are there. Like, so for example, you are having some chips are there like this. Some chips are internally, all these things internally, the chips are there. You have some other controllers are there. You are having audio devices. You are having a video devices inside connected, right? You are having something like PCI based devices are there like this. So many small, all these are chips, guys. Chips inside your RAM, inside your laptop, actually. Same thing will be there in a big server also. Tomorrow I'll show you. I'll show you the diagram. If you see the diagram, you will see that actually so many internal chips are there, so many internal devices are there, with all are there within a server inside. Now, what I'm saying means now, okay, this is all okay. Okay, this is my laptop actually. Now, what I will do, time being, I will try to remove this because I need some space, guys. This is the screen or the monitor. I will remove this. It is there, but for our understanding, okay, I want this space actually. That's what I'm removing this. Right now, what happened? Right here, what happened? Your laptop will be, or your server will be switched on to some power supply like this. Now, as soon as you switch on the power supply, what happened? Right? What happened? Right? The power will go and it will trigger to the CPU first. I try to trigger the CPU like this. So as soon as the CPU is triggered, the CPU will get initialized. Initialization means it will start working, it will start checking. Okay, there's so many operations happen, all those things inside the CPU. Don't worry about that. Okay, what is it? We need not to worry that much actually. Once the CPU is initialized, all other devices like RAM, memory, hard disk, so many chips inside which are there, all this hardware will get initialized. So this process we call it as a BIOS, basic input output system. So all these are under the boot process only, guys. Under the boot process, what happened, right? The first thing what happened is a BIOS. So BIOS will do initial bootstrapping, which all the devices which are connected, right, it will get initialize everything, right? Like this happens. Once all the devices connected, what will happen, right? Your CPU will try to check where, okay, what happened, right? Once the BIOS is done, what happened, right? It checks actually like where is the information about the operating system. From where I can load the operating system. You can load the operating system on the hard disk, right? Because if your Windows is there, you will be having something like a C drive like this, right? In the hard disk, you'll have something like a C drive like this. This is the C drive. C drive like this, right? If you go here, like this is my C drive, right? In the C drive, inside the C drive, I have an operating system actually. What is that operating system? Windows operating system. So now what happened, right? After the BIOS is done, it checks actually like where exactly I can find the information about the OS. Okay, it is then the hard drive. Okay, then what happened, right? Your bootloader will come into the picture actually. Bootloader is a program. It's a program which is invoked by your BIOS. What the bootloader will do, bootloader will try to check where exactly the information about the operating system, where I can find it on mine. I can find it out in the hard disk only, right? Or hard disk. So what happened? It goes to the C program files, bootable files, and finally what happened? It tried to check, okay, I got the operating OS image here. I got the OS image. So I got the OS image and also I got the file system image. So these are the two important components which will be there here in your C drive. Sorry, guys. I think I did some. Yeah. So in the C drive, it found the OS image and the file system image. So what it will do that it will, so this RAM memory I'm removing now. I'm expanding this RAM memory now. Now what it does, right? Right, what the bootloader will do that it will take this RAM memory. It will take this RAM. This is a RAM memory. I'm drawing a big diagram. This is nothing but a RAM memory. A RAM memory. And this RAM memory, what happened? It will divide this whole RAM memory into two spaces like this. It will divide into two spaces. This one is called it as a user space. Or even you can call it as a user mode also. Something, both are same. If I can use space, and this is called as a kernel space or kernel mode, we say. So what your bootloader will do, this bootloader program, it will try to load this OS image and your file system image into your kernel space. So your OS image will be loaded here. Your OS image and file system image will be loaded here in the kernel space of the RAM memory. So once it loads, later what happened, right? There are many other programs as a part of boot process. There are many other codes are getting called. Like for example, setup code. Don't you know to worry all these things. Setup code. The fourth stage is start _32. startup underscore 32. And finally, start underscore kernel. You need not to worry, guys. You might think, what is this? Rajesh is saying something peculiar, which I'm not understanding at all. Don't worry. So these are the 5 stages of the boot process. So all these 5 stages, what happened, right? It will help you to make sure that you will get a login page where you can log in with the username and the password. You can log in. Till that phase, entire phase, we call as a boot process. So what happened here, after these 2 images are loaded into the RAM memory, what is happening that here, what is happening that the OS is getting initialized, your file system is getting initialized. Finally, what happened, right? Once it is getting initialized, you will get the OS Linux kernel like this. You will get a OS operating system. You'll get like this. OS will come up here actually, or else you call the kernel will come up. Kernel will come up here like this. So Rajesh, this is the OS? Yes, sir. So now as soon as I get the OS, I will get a login prompt where I can log in with the user. So here what happened, Rajesh is a user. What he will do that, he will give some username, something like a Rajesh. And the password for my system is Rajesh @123. Something like this is my password. And that is my, Rajesh is my username actually. This is my username actually. Right? See, the user will log in a user space, but the OS will be running in the kernel space. Am I clear, sir? Till here? So this entire process is called the boot process. Rajesh, is this the same process happens even in Windows, even in Linux, even in Mac OS, even in any embedded OS, anything you take ARM processor, boot processor, boot board, or something Cortex ARM board, or it's like Beagle board, or you call it as an x86 architecture or Alpha architecture, or any of your real, like any of the high-end server which is used in an organization. Sparks processor, IS64 processor, any hardware, anywhere you take in the world, okay, all the operating system image will be loaded, everything with the help of a boot process only. And a boot process will have several steps within it. It has a BIOS, it has a bootloader, it has setup code, startup, start kernel. Maybe the naming convention might change from one device to other device, but the idea is same only. I mean, the method is same only. It executes some series of some steps where the operating system will get loaded into the memory and where the user can log in, where he'll get the prompt where the user can give some user and password and he can log in. Till that entire stage where usernames Rajesh, like Rajesh logs in with his user and password, where he logs in, all this phase we call it as a boot process. Sir, am I clear, sir, till here? पंकज भाई, कुछ समझ में आ रहा है?
Yes, sir.
Does it make sense? कुछ समझ में आ रहा है?
Yes.
Okay. नवीन, राजीव भाई, सुकेत, वेदांत,
यस सर, समझ में आ रहा है.
ठीक है. बस इससे ज्यादा नहीं समझना, बस इतना ही काफी है मतलब अभी के लिए. अभी आप राजीव विल आस्क, somebody will ask, सर ये सब पता तो है लेकिन थोड़ा इन डिटेल जा सकते हो किस चीज में? या हम जा सकते हैं, वी कैन गो इन डिटेल, बट अभी के लिए हमें नहीं चाहिए अभी इन डिटेल. बाद में अगर 1 घंटे का क्लास सिर्फ हम बूट प्रोसेस में ही करेंगे हम लोग, तब मजा आएगा कि बूट प्रोसेस होता कैसा है, कैसे अपना डिस्क कैसे डिवाइड होता है पार्टीशन से. उसमें एमबीआर बोलते हैं, यहाँ पर इसको एमबीआर बोलते हैं, मास्टर बूट रिकॉर्ड में क्या होता है वो सब हम लोग डिस्कस करेंगे लेटर. सेटअप कोड में क्या होता है, स्टार्टअप कोड में होता है, स्टार्ट कर्नल में एग्जैक्टली क्या होता है इंटरनली. तो अगेन सर, डेवऑप्स के लिए इतना जरूरी है? डज इट रियली रिक्वायर फॉर? नो सर, इतना जरूरी नहीं. इनडायरेक्ट बूट प्रोसेस इतना जरूरी है. हाँ, अगर आप इंटरव्यू में जाते हो, इफ यू गोइंग टू इंटरव्यू, इफ यू एक्सप्लेन दिस प्रोसेस, वो चुप हो जाएगा आपके सामने. वो इंटरव्यू कुछ बोलेगा नहीं आपको. ही विल नॉट टेल एनीथिंग, ही विल नो दैट ओ दिस फेलो नो समथिंग. कुछ नहीं बोलेगा. ये सर, ये सब कहाँ यूज होता है सर? ये सब डेवलपर्स लोग उनको चाहिए, दे नीड इट बिकॉज दे हु आर वर्किंग ऑन ऑपरेटिंग सिस्टम लेवल, हु आर वर्किंग ऑन अ सिस्टम लेवल प्रोग्रामिंग, उनको बहुत इन डेप्थ जरूरत है. जो एम्बेडेड सिस्टम में उसको ज़्यादा जरूरत है, जो डिवाइस डेवलप प्रोग्रामर में उसको ज़्यादा चाहिए. हाँ, सिस्टम एडमिनिस्ट्रेटर को, जो लिनक्स सिस्टम एडमिनिस्ट्रेटर किया हुआ है, उसको भी चाहिए. लाइक फॉर एग्जांपल कृष्णा साई, ही इज वर्किंग ऑन एडमिनिस्ट्रेशन लेवल लिनक्स, राइट? सो यू माइट नीड सम लिटिल बिट इन डिटेल. व्हाई यू नीड इट? बिकॉज अगर सोचो, when you're switch on a system, operating system itself is not loading, right? You will understand why it is not loading. From which path it is taking the VM image, which path it is taking initard image, why both are not getting loaded, why it is not getting initialized. When you start troubleshooting, you will understand, okay, there is something happened, man. In some step, some file has been corrupted. I got to know. तो उसके लिए ट्रबल शूटिंग के लिए देर विल बी ट्रबल शूटिंग स्टेप ऑल्सो, हाउ टू रिकवर बैक दैट फाइल, how you can make sure that you can troubleshoot and again you can make the OS up, right? So there is something will be there, something you have to take some secondary disk you have to take, or something there's a backup will be there. You have to take a backup recovery plan where you have to take a USB, plug in it. Okay, you have to boot from your device, from USB device, and then you have to mount all those file systems where actual file system is there, and then troubleshoot it. There are some series of steps are there which you have to follow to start troubleshoot it actually. So when you're aware of certain information like this, guys, you will be able to better troubleshoot it. Now you understood like why I'm repeatedly saying troubleshoot, 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 because DevOps or anything is all about troubleshooting only. Okay, so now Rajesh is a DevOps engineer, senior DevOps engineer, senior architects in DevOps and cloud, platform engineering team, SRE guy, site reliability engineering, okay, and data engineering guy, AI guy, MLOps guy. Does all these people know this, all this in detail? Yes, sir, they will know all these things in detail. Because if you in the organization, if you go to any, if you go to organization, if you check for any very senior SRE engineer, site reliability engineer, or senior platform engineer, senior architect, they will know all these things in a very better way. That's how they've reached that position. Since we are a new learner, we have to learn from the very basic way, get into, and we need to reach to that stage where we can become architect, where we become an individual contributor in the organization, where they will be dependent upon us. We have to do that work actually. Like in Japan, right? I'll be in a senior SRE engineer, so they'll be giving a lot of tasks to me to work on it. I should be capable enough to complete those tasks. So I should have good knowledge to troubleshoot it or add on any new features. Everything I should have so that I can able to comfortably do the task. They will ask me also, Rajesh, this is the task. Yeah, I understood. How much time it will take? Sir, according to me, I think this will take 4 days of time. Are you sure? Yes, sir, I'm sure. So 4 days task, guys, I have to do it in 4 days. First day, what I did, I have to show the to my lead. I have to show, sir, this is what I did my progress in first day. Second day, this much. Third day, sir, I done, sir. I'm doing some testing. Okay. Fourth day, sir, I did it, sir. Sir, if you don't mind, can I take another half more day? Yeah, I'll just take it next half day, but please deliver by next day afternoon. Yes, sir. Tomorrow I'll come on the Friday. That is the fifth day. I would have already tested everything on the fourth day. Fifth day मैं demo करके दिखा दूंगा सर ये मैंने implement किया है. They'll get confidence on me. Okay, Rajesh is capable enough to do it. So whenever you go in the organization, you work as a platform engineer, you work as an architect, any level, sir. Whatever the time you take now, you fix with the timing, and you have to deliver your completion of that task with that. How you get all these things with only with an experience, with the knowledge, when you worked in a very when you worked in a very good in the organization, right? Right, then you'll be able to estimate what is the time it will take to complete this task, and you'll be able to achieve it. Am I clear, sir? So all these things happen industry, guys, in the organization. Whenever in between when I'm taking topics, right, I'll be keep telling what inside the company happens, what kind of projects they work, how they deliver it, what kind of engineers you will find it, right? If you join as a junior DevOps engineer, what work they will give you, how you have to talk to your seniors, okay, how you have to draft an email, okay, how you have to keep a loop for all the team stakeholders like developers, testers, your senior people. How do you everything? We will slowly one by one in each and every class you will be learning many things, all these things, so that you will get a complete picture. Okay, when I enter into an organization as a DevOps engineer, how I have to be as an engineer, what kind of work will be given to me, what kind of task, some will be a repeated task, some will be a very new task will be given, how I have to tackle all those things. We will discuss all these things in our in every day actually. In every day's class, we will be discuss something, right? So guys, today today's, I think I will stop it. So today we learned something important, like this is what we understood, Rajesh. If you go to a diagram, okay, some user space, some kernel, sorry, some user communicating, but there is something shell and HL coming. Okay, kernel is something which is made up of this file system. We understood each and every subsystem to just one line information, not that much. Okay, that is good. So we learn about something, what is file system does, what is IPC. IPC is a part of your process management only. As I said here, your process management here, the process management there, process management has that IPC also. Internal communication process is done by the process. So, okay, this is something we learned. Okay, we learned something about the kernel now. What is the boot process happen? How, what exactly happen in boot process? How the image will get loaded into the RAM memory, the OS image and the file system image, which we call the init image in Linux, that is loaded by your bootloader. So what is this bootloader? Bootloader is a special program which is called by the BIOS, and which loads the operating system and file system image into the RAM memory. That's all you have to say. Am I clear, sir? So what the bootloader does, bootloader is a special program. So in Linux, actually, Linux, the bootloader name is GRUB, Grand Unified Bootloader. That's the name of the bootloader in Linux. Whereas in Windows, we call it as a NTLDR bootloader. So that is somebody asked you, Rajesh, which is a bootloader used in Windows? Sir, NTLDR. Which is in Linux? It is GRUB, sir, Grand Unified Bootloader. Okay. So you can even Google it out, sir. Nothing to worry. Don't worry anything, guys. Everything is freely available in the Google. A lot of people have posted a lot of articles. GRUB boot loader in Linux. See, GRUB bootloader, the complete step-by-step tutorial. See, you will get all these things, guys. See, BIOS, GRUB stage 1, stage 2, kernel boot. See, this one, all these things we can effectively explain you guys. This is fantastic. I'm saying, if you start explaining all this, you will actually learn how the boot process takes place. This is something, I mean, if I explain everything, guys, you will become mad actually. How this happens, everything, Rajesh, so many things are there. I can discuss all these things. I need 1 hour, 1.5 hour class on this only. But again, the question comes, Rajesh, do you have to know that much in detail? Not really. When it comes to the boot process, not really. Yeah. For architect level, as I said, architect level, senior SR engineer, they will know all these things, guys. If I go and discuss with them, they will able to tell me something. Okay, grub.cfg is there, Rajesh. In that grub.cfg, yeah, you will get some configuration files like this. You copy this path, see, you copy this, and you just give in a net like this. See, you will get the file itself actually like this. You'll get the code only. You'll get all the codes details, right? Like this, you'll get. This is what I was talking about. See. Oh man, do you have to learn all this? See, did you heard something at that time? I was saying when I'm telling OS image and the file system image. I said in Linux it is initRD image. I told you, right? So can you see that naming initRD? And for the OS image, I was saying something like VM Linux, VM Linux. See, VM Linux. See, this is your operating system image in Linux, and this is your file system image. Now some questions will come to your mind. What is this file system image, Raj? What is operating system image? Do I have to know more in detail? Don't worry, sir. We will see all those things. Don't worry. We'll see all those things. Yeah. Krishna, what you're saying is right. MBR, bootloader, grub, init, run levels. At the time of patching, VM Linux is corrupted. Yeah. All these things is a troubleshooting only. Good. So guys, I would also say one more thing, that please unmute yourself and talk in the class. Okay, I would restrict to do chat and say something in chat. No, Krishna, always say, open your mouth and say, Rajesh, BIOS, boot prompt, init run levels, because other people will listen to. Always, people will not see this chat everything always. When we talk, right, when you discuss, when I tell, right, that way we will be hearing those words and people will get to know a lot of people. Some people, Pankaj will get, Rajesh, what is run level? What is this init? He will get to know all these things. He will hear that word and he will be able to even Google it out, or he will ask us actually. So please, always guys, it's an humble request. I will fold my hand and I will request all of you, please unmute and speak with me. That is better actually. Like whatever is there. Whatever is there, sir, don't fear, sir. You speak anything with me. We are there to discuss only. See what I'm doing here. I'm just exchanging. I'm just telling. I'm just giving my knowledge, or I'm just telling you. When we start talking each other, right? When we all of us will start discussing in a class, right? It is nothing but it's a sharing of our knowledge, and sharing of our knowledge is the best practice, guys. That's how you will learn many things. In an organization also, when you go and when you discuss with your seniors, when you discuss with your architects, he will share all his knowledge in front of you. Right. When I was at Lumen Technologies, my previous organization where I worked for 10 years, right, I used to share all the knowledge with all my colleagues, with all my subordinates, with all my people who are reporting to me. When I talk, right, they listen to me and they'll ask some question and I'll answer it. So that's how the discussion only what happened. We'll be learning many things. When you come in a front of a system, when you work, right, all those knowledges, whatever you heard, right, that will all come to the picture. It'll all come in front of your eyes. Okay, then you'll better understand the system, or you'll better understand the tool or the technology. So when you learn the things, first learn through exchanging the knowledge between the people, between two people or between multiple people, and then when you come in front of a system, you will come you all your knowledge it will come in front of your eyes, right? All you cannot gain all the knowledge by just sitting in front of system, guys. No, first you need to gain the knowledge means you have to first read, learn, read the articles, read the PDFs, watch the videos, discuss with your colleagues, with your friends. Yeah, that is how you gain the knowledge. First you need to gain that knowledge in your mind, and then when you come in front of a system, right, then all the knowledge you will be using in at your work actually. That's how it will be, right? So always first open your mind, try to hear many things from many people, and then like learn yourself. And of course, as I said, you need to put a lot of effort in learning everything. You need to read a lot of PDFs, articles. You need to discuss with seniors. You need to discuss with many people. Discuss with me. Go to the videos. Try to learn it. That is how you need to put every day's effort. You will learn in a better way. Right. So guys, I will not tell all this thing again because I know that I will be sticking to the topic only. Just for the initial stage, I'm saying that please learn in a better way. Okay, and try to listen, try to read the articles, PDFs and all, which I will send it, notes and all, so that you will be intact with the knowledge. And if you get any doubts, please ask me. Okay. Okay. So I think guys, that's all for today. Okay, I will not be continuing much. I will stop it because it's already 11:30 here. 12, sorry. I have to sleep and wake up by 5:30 morning. So I'll stop it here, guys. If you have any questions, please let me know. I know I'm been too much talkative. I talk, but still, you need to interrupt me in between and ask some questions actually. Okay. Vedant, Suket?
Rajesh,
Yes, Krishna.
will you teach these incidents in Linux?
Incidents means what?
Like
Troubleshooting.
MBR issue, grub issue, kernel issue.
I can, but what happened? No, Krishna, I can, but what happened? No, one problem I will tell you. See what happened? No, suppose for example, if you are troubleshooting some grub issues, I need to I need to have a GUI mode. It means that I need to have a full desktop installed in my laptop actually, which I don't have it. That is one thing.
Okay.
Secondly, okay, that is one thing. Secondly, one thing, Rajesh, can you show that in a command prompt? Not really, because I need a GUI to show to show how to enter into the grub mode and how to troubleshoot it. That is one thing. Second
Yes,
is, yeah, second is something like when your operating system get corrupts actually, or when your file system get corrupts, okay, again you need to go to the grub prompt and you need to locate that those files, and you need to just load the kernel and show like, okay, the file is corrupted. It means that I need to have some corrupted image. So again there,
yes.
yeah, there what happened, I have some challenging to get a corrupt file actually. Okay, that is one thing. And the third important thing, what are the other things you ask me, man? Troubleshooting, what happened? To some extent, I will show the troubleshooting. Yeah, I mean, whatever I can show in the command line and all, I will just show you, okay, this is a command you have to run, man. Like, okay, dump E2FS command, you have to run it so that you will check when any
Like
corrupt kind
file
of
system will be in read-only mode. So
yeah,
how
yeah,
to
read.
troubleshoot those things?
Yeah, correct. Those things and all small things I will show so that you'll get some ideas actually. But whatever if you want me to theoretically explain, yeah, I will theoretically explain with writing. And even if you want, I can even come in a camera also, in a video camera, so that you will see me. You will feel like, okay, Rajesh is speaking to us and he's saying something. Yeah, you will get the feeling that, okay, he's explaining in a way it works in an organization. So you'll get that feeling when you hear to me. You got it?
Yes,
See,
yes.
troubleshooting something, how you know, Krishna, troubleshooting something, first you have to sit next to one person who is an expert guy. You have to see him how he's troubleshooting. Once you learn that art of, okay, once you learn something, no, then when you get that opportunity to troubleshoot, no, you need to struggle a lot, man. So once you struggle a lot, then again, if you're not getting a solution, go back to the same person, catch him, say that, hey man, Rajesh, I found this issue, man. Can you please help me? I'll come and sit next to you, troubleshoot, explain you. Then you will learn it. That is how we learn certain troubleshooting in the organization. Okay, that is how slowly, day by day, when you start working, right, you will see that one day, when some few years, you will see that you become expert in that. You don't need any other help at all. You will do yours. You will solve all a problem yourself only. And of course, I mean, there should be strong learning. That's what I'm saying. When you should strong learning, and you should be learning, you should be lucky enough that you will get all those issues, and you should be lucky enough you have to pick those issues and you need to fix it actually. Sir, when you start taking the such kind of a task or a work where there's a lot of troubleshooting, you'll get a lot of pain.
while troubleshooting. I'm sure that you'll get pain. Pain means you'll be scratching your head. How to fix this issue, man? I'm finding very difficulty. That scratching of head is required, sir. And that burning of your head is required at that time. That will make your learning, a lot of learning it will make you, sir. And I'll guarantee you, sir, when any person scratches their head a lot at work, it could be DevOps or it could cloud, and when he works on this on troubleshooting some issues, or else fixing some issues, or else setting up a new thing itself, then you will see that person's learning curve will go like a rocket, sir. So I will come with all such things, guys, what we exactly do. When I take a Terraform, when I take Docker, I will exactly tell in the industry how things works with the Docker, and what are things we do to build an image, what are the real challenges we'll face in Docker, what are the real challenges we'll face in Kubernetes, we'll face in Ansible. Such things, when I share that knowledge, I think that will definitely enhance your learning also. Right, with all examples, with in detail, with all example, along with that in industry how it works, if I tell, and with the project level, and with the interview question answer discussion, or what they ask in Ansible, what they ask in Docker, if I explain all the things in a serial way, no, I think you'll be able to learn in a better way in each and every tool, sir. Same thing I will use in cloud also. When I start taking AWS now, you will see that I'm covering so many services one by one. I will show all the practicals, and finally you'll see that, Rajesh, this practical is so much hectic, man. Ajit will say me, I'm sure that, सर आपने क्या सर इतना प्रैक्टिकल्स किया, 1 घंटे का प्रैक्टिकल किया आपने, बोलोगा, ही विल से दैट 1 घंटा हम कैसे रिमेंबर करें सर, हम कैसे करें सब, नो प्रॉब्लम भाई, एक एक स्टेप 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 करते जा, एक एक करते जा. तो व्हेन यू डू द कंप्लीट स्टेप, आपने पूरा सेटअप कर दिया, ठीक है सर, ये सेटअप कर दिया मैंने, इसमें और क्या क्या ऐड ऑन कर सकते हैं, ये भी कर सकते हैं, ये भी कर सकते हैं, ठीक है सर. इशू आए तो कैसे ट्रबल शूट करते हैं, हाँ ऐसे ट्रबल शूट करते हैं. सो राजू वुड हैव लर्न सम 50-60%. Jab, when he sees me doing all these things, when Rajiv will sit and do himself by his own right, then another 20% will add on to his knowledge. जब वो खुद करेगा, उसको कॉन्फिडेंस आ जाएगा, उसको पता चलेगा अच्छा ऐसे चीजें होती हैं, ओके दिस हाउ इट वर्क्स एक्चुअली. ये चाहिए सर, ऐसा नॉलेज, ऐसा प्रैक्टिस. सो वन थिंग गाइस, आई विल ट्राई टू टेल यू इन अ वेरी वेरी ऑनेस्ट वे एंड वेरी वेरी स्ट्रिक्ट वे, दैट अगर आप लोग कोई भी, इफ यू गाइस आर नॉट डूइंग प्रैक्टिस, आप लैब में बैठ के सिस्टम के सामने बैठ के आप काम नहीं करोगे, और सिर्फ वीडियो देख के जाओगे और वीडियो से सुनोगे या फिर नोट्स पढ़ोगे, आई एम वेरी सॉरी टू से दैट गाइज, यू विल नॉट लर्न लिनक्स, यू विल नॉट लर्न डेवऑप्स एंड क्लाउड. नो, इट्स नॉट पॉसिबल. और कोई भी कल को कुछ भी आता है, आप नहीं पढ़ पाओगे शिक्षा, क्योंकि यू हैव नॉट डिड एनी प्रैक्टिकल्स. Practical is the only way to convert your knowledge into an actuality. Actuality means आप जब knowledge को convert करके आप lab में करते हो ना, तब आपका knowledge enhance होगा. And that is what I need from you all. अगर आप लोग पूरा practicals कर लेते हो, अपने आप एक बार आप कर लेते हो, थोड़ा थोड़ा ट्रबल शूट भी कर लेते हो, यही knowledge आपका काम आएगा इंटरव्यू क्रैक करने में. The same knowledge will be used to crack the interview when you do a practicals. And I'm telling you very seriously and very promptly, I'm saying that if you are not practicing, I'm sorry guys, you will not be able to crack any interview. You will not even get a good knowledge also. You will be having very shallow kind of a knowledge. आप interview में जाओगे, you will forget everything. Most of the answers, you don't know how to answer it actually. आपको पता नहीं चलेगा मैं कैसे आंसर करूँ उस क्वेश्चन, बिकॉज लैक ऑफ प्रैक्टिस, लैक ऑफ लैब एक्सरसाइजेस, आपने किया नहीं ठीक से. आपको जब पकड़ नहीं आएगा, लैब से पकड़ नहीं आएगा ना, आप नहीं समझ पाओगे चीज, एंड यू नॉट बी एबल टू क्रैक इंटरव्यू. क्रैक भी कर लिया आप, इफ यू क्रैक्ड आल्सो, इफ यू गो इनसाइड द कंपनी वेयर दे गिव सम टास्क टू यू, यू नॉट बी एबल टू कंफर्ट टू इट. So what I need from you is that not only cracking the interview, not only gaining the interview, not only gaining the knowledge, but the main important is that when any task is given to an organization, how you will tackle that task, how you do the task, how you start working on that task. That is what I need from you all. That is a real challenge. That is what all people are behind it. Okay, Rajesh, मुझे task मिला. You know, so many people call me and say, Rajesh, I got this task when I was doing, I got held here. What to do? Can you help me out? मतलब वो जाके फंस जाते हैं एक जगह, and they start asking the question. So it is not okay. They have did something, but what happened? I understood. Okay, what is his problem about? Then I'll start asking. Okay, आपने ये किया? Have you did like this? Have you did that? He'll say no. He'll say yes, or he'll say no, something. Then I'll say that do this, do this, do this. When he start working again, he will try to he will try to show a progress in his work. वो थोड़ा progress हो जाएगा, करते रहेगा. Finally, you see that he would have completed work also. तो ये चाहिए हमें. We need that one where you take any task in an organization, when they assign you, slowly progress करते रहो, right? 100% है, पहले मैंने 10% कंप्लीट किया, ओके गुड, 20% किया, 30% करते करते कुछ इशू आया, हाँ आई नीड टू गेट अ हेल्प, somebody you ask help, or you overcome from that, go to the 40th% completion, 50th, 60th, you could see that and someday you will finish that 100%. ये चाहिए हमें. We need this one actually. We need a progressive improvement in everyday work, what you do in that task actually. So how you will do all those progressive increment when you started learning, when you started learning DevOps and cloud or whichever technology in a very in detailed way, and when you did a lab access, that all those knowledge will help you to do a better work at the organization. Is it clear, Naveen?
Yeah, yes, Ravi. Yeah.
Sure, sir.
Yes.
Thank you
Yes,
then.
sir.
Guys, that's all for the day. If you have any questions, let me know, or else we'll wind up the class. Okay, no questions. So thank you, guys. Thank you. Then let me stop the recording. And guys, this recording I'll share it tomorrow because I'll sleep now. I'll not be able to share the recording immediately. Tomorrow I'll share this now recording. Okay, let me stop the recording.